Good morning. Good morning, everyone. Are we live? Tell me in the chat section. Am I audible? Am I audible? Is the audio clear? Is the video clear? Good morning, everyone. Hello, Richu. How are you? Good morning. A very good morning to everyone. Is the audio clear? Please tell me please give me a thumbs up in the chat section if the audio is clear. Hello, Richu. Hello, Junior. Dynamo. Hello, Solo Guy. Is the audio clear? Tell me in the chat section. Is the audio clear? Yes. Okay. Okay. Great. Today is organic chemistry class at 11 a.m. At 11 a.m. we are having regular classes. One day we are having physical chemistry and the other day we are having organic chemistry. So today we are going to have organic chemistry class. Daily at 11 a.m. we have our classes. All right. So very good morning to everyone. I welcome you all to Unacademy, India's largest education platform. This is Let's Crack NEET UG in English. Let's crack NEET UG in English platform. All right. So let me first introduce myself. I am Nitesh Devnani. I have 5 years of teaching experience in chemistry and I have taught over 2000 plus students for NEET, and they have got some great marks in their NEET examination. So if we will work together, we can surely achieve your target also, and our target is to score 170 plus in chemistry. Alright, our target is this. Just you need to attend these classes regularly. We will surely reach our target. Alright. So let me tell you about the subscription plan of Unacademy. It is very beneficial, very useful if you subscribe to it. You need to download this Unacademy learning app. You need to download this in order to have that access to your subscription plan, as well as you will have a lot of free classes also there. So just after this session, download this app. Alright, whenever you buy the subscription, you will have daily live classes, you will have live tests and quizzes, you will have structured courses, as well as you will have unlimited access. Unlimited access means you can avail all these things whenever you are comfortable. Alright, whenever you are comfortable, you can avail all these things. There are some free classes on the app. The app name is Unacademy Learning App. Alright, there are some free classes also. We will also have free classes there. These are the educators on NEET for the NEET UG platform. And let me tell you about the pricing. The 12-month price, whenever you buy the subscription, you need to apply this code Nitesh YT. Nitesh is my name, and YT. You just need to apply this code for 12-month course. You will get it 27,000 rupees, and 24-month course you will get it 32,400 rupees. Let me remind you one thing, that the Unacademy, the price hike is very soon going to happen. All these prices are going to be increased very soon. So if you are planning to buy the subscription, I would recommend you to buy it as soon as possible and apply this code Nitesh YT. You will get 10% off. Alright. So very good morning to everyone. Today again it would be a little bit big class. It will be a big class today because we need to cover a lot of topics today. We need to first cover what is aromaticity, then inductive effect, then hyperconjugation. We are all covering this in today's class, so this will be a big class, and this would be a very interesting class. So yes, a very good morning to everyone. Good morning, Ritu. Good morning. Today we are going to study organic chemistry. Ritu, we have our organic chemistry class today. Alright, so just give me a thumbs up in the chat section if you guys are ready. Just give me a thumbs up in the chat section if you guys are ready. This will be a long class. Please be with me for the entire class so that you are very much able to understand each and every concept. All right, so let us start our course. We are going to study about first aromaticity. See, these are different type of compounds. All right, aromatic compounds are different type of compounds. See, in aromaticity we deal with three type of compounds. Just please focus here. Three type of compounds. The first compounds are aromatic compounds. All right, now aromatic compounds, aromatic compounds are also known as extra stable compounds. They are very stable compounds, aromatic compounds, but you need to identify them whether they are aromatic or not. You need to identify them. So conditions, what are the conditions for a compound to be aromatic? What are the conditions for the compound to be aromatic? See, there has to be some conditions. You need to identify whether a given compound is aromatic or not. So there must be some conditions. If it follows all the conditions, then we say it is aromatic. Otherwise we say it is not aromatic. Are you getting my point? Alright, so conditions are, it should be cyclic. The first condition is it should be cyclic. The second condition is it should be planar. The structure should be in one plane. For planar, the hybridization should be what? sp2, sp or sp2. Alright, whenever if there is hybridization is sp3, we say it is out of plane. So for the structure to be planar, the hybridization should be either sp or sp2. Alright, getting my point? Third is conjugated. Conjugated means, conjugated system means resonance possible. If resonance is possible, then we say that system is conjugated. Alright, and the last rule is should follow Huckel's rule. Should follow Huckel's rule. That is it should have 4n plus 2 pi electron. Let me explain you, where n equals to 0, 1, 2 and so on. That means 4n plus 2 pi electron. In place of n, just put 0. If you will put here 0, you will get 2 pi electron. Alright, if you will put 1, you will have 6 pi electron. Now if you will put 2, you will have 10 pi electron. So if there are 2 pi, 6 pi, 10 pi, 14 pi, this much pi electrons, it means it is following Huckel's rule. Alright, now what are pi electrons? What are pi electrons? Electron participating in resonance. Electron participating in resonance are known as pi electrons. Alright, so the number of electrons those are participating in resonance must be what? Either 2 pi, either 6 pi, either 10 pi. This much pi electrons should participate. Alright, I'm going to give you a lot of examples also. Yeah, good morning Rajni, good morning Sajjan, good morning. Alright, so it should be cyclic, it should be planar, it should have resonance, and it should have 4n plus 2 pi electrons. Alright, 2 pi, 6 pi, 10 pi, like this. So is this much clear to all of you? Now shall I give you some examples of it? Give me a thumbs up in the chat section if this much is clear to all of you. Let me give you some examples. Let me give you some examples. See, this is your benzene. This is your benzene. All right. Cyclic. The structure is cyclic. Great. Uh, is it planar? Yes. Why? Because see, let me tell you, let me give you a trick. If all the bonds are single, this carbon single bond carbon, this means the hybridization is sp3. Carbon double bond carbon, this means the hybridization is sp2. Alright, and carbon triple bond carbon, this means the hybridization is sp. So alright, so see, you have your double bonds, so it has hybridization sp2. So it is what? It is what? Planar. The structure is cyclic, the structure is planar. Resonance is possible. What type of system is there in resonance? Give me a give me answer in the chat section. What type of system is there in the for the resonance? What type of resonance is there? Double, single, double. Double, single, double. That type of system is there. So resonance is also possible. And let us calculate pi electrons. See, how many pi bonds are there? 3 pi bonds. There are 3 pi bonds, no? See, if there is carbon double bond carbon, so it has 1 sigma and 1 pi bond. So here it is pi bond, here it is pi bond, and here it is pi bond. So it has 3 pi bonds. So 3 pi bond means how many electrons? 6 pi electron, because one bond is equivalent to 2 electrons. So 3 pi bond is equal to 6 pi electrons. Now 6 pi electrons means it is following Huckel's rule. It is following Huckel's rule. So all the 4 conditions are true. So it is what? Aromatic. It is what? Aromatic. A is for aromatic. Is this much clear to you? Great, Nagendra. Great. Is this much clear to you? Give me a thumbs up in the chat section. Is this much clear to you? Give me a thumbs up in the chat section. Come on, everyone. Everyone, please be active on the chat section. Yes. Let me give you some more examples. Now suppose this is your compound. This is your compound. You need to identify whether it is aromatic or not. Alright. Just check all the conditions. Whether it is cyclic. Tell me in the chat section whether it is cyclic. Just tell me in the chat section. Is it cyclic? Yes, it is cyclic. Yes. Is it planar? Yes, it is planar, because it has, see, this and this carbon is sp2, as well as this positive charge means the carbon is sp2. So it is planar also. Resonance possible? Conjugated system? Tell me in the chat section, is resonance possible? And what type of system? I've explained you all this in resonance. What type of system? Double, single, empty orbital. See, double bond, single bond, and this positive charge means empty orbital. So resonance is also possible. Alright, now we need to check pi electrons. Electrons which are participating in resonance. So only this pi bond is participating in resonance. This positive charge means it doesn't have any electron. So only this pi electron is is participating in resonance. So it has 2 pi electron. One bond means 2 pi electrons. So it is again aromatic. See, for 2 pi electrons also we have aromaticity. Got it? Yes. Great, Rajani, Nagendra, Richu, Sajjan. Fantastic. Solo guy. Yes. Yes. Great. Okay. Now let me give you one more example. Let me give you one more example of it. This negative charge means lone pairs. Come on. Tell me in the chat section. If this is aromatic and how many pi electrons it has. Tell me in the chat section. Tell me in the chat section if this is aromatic or not, and how many pi electrons it have. Pi electrons means number of electrons participating in resonance. See, this is cyclic. Planar, yes, it is planar because every carbon is sp2 hybridized. Okay, resonance possible. Double bond, single bond, lone pair. Yes. Now we need to see pi electrons. See, this bond, this pi bond is participating in resonance. Yes. This pi bond is participating in resonance. Yes. These lone pairs are also participating in resonance. So pi electrons are those electrons which are participating in resonance. So all these are participating in resonance. So two bonds, 4 electron, as well as this lone pair. So this means it has 6 pi electron. So again it is what? Aromatic. Again it is what? Aromatic. Alright, is this much clear to all of you? Now tell me this one more. Again, tell me this thing. This is known as furan. Common name is furan. Tell me, is this aromatic or not? And if it is aromatic, tell me how many pi electrons it has. Come on. Great. Sajjan, Nagendra, Rajni, Solo Guy. Great. Yes. Cyclic, aromatic. Cyclic planar. Yes, the structure is planar. Resonance possible, double, single, lone pair. How many pi electrons? See, one pi bond here, one pi bond here, as well as these electrons are also participating in resonance. So it has 6 pi electrons. So it is what? Aromatic. Very good. Solo guy, Sajjan, Rajni, fantastic. Nagendra, great. All right. So now you are very much clear with aromaticity. All right. You can identify whether a compound is aromatic or not. And aromatic compounds are what? Extra stable compounds. They have great stability. All right. They are very much stable. Now the second type of compound is anti-aromatic. Anti-aromatic compounds. Second type of compounds are these anti-aromatic compounds. These are extra unstable. These are extra unstable compounds. These are not very stable. These are very unstable compounds. All right. Now again we need to see what are the conditions. What are the conditions for a compound to be anti-aromatic? See, just pay attention here. The first condition, cyclic. The structure should be cyclic. Second condition, it should be planar. Planar means hybridization up to sp2. Alright. 3 means conjugated system. The system is conjugated. Alright. The system has to be what? Conjugated. So this means the resonance is possible. Fourth type of system is it should have 4n pi electron. 4n pi electron, where n equals to 1, 2, 3, similarly like this. Just put 1 here. Come on everyone. Just put 1 here. If you will put 1 here, what would be your answer? 1 means 4 pi electron. Just put 2 here. 8 pi electron, 12 pi electron, and so on. If it has 4 pi electrons, so it is what? Anti-aromatic. If it has 8 pi electron, it is what? Anti-aromatic. If it has 12 pi electron, it is what? Anti-aromatic. So all, see, first 3 conditions are same. The last condition is 4n pi electrons. Is this much clear to you? Let me give you some examples of it now. Give me a thumbs up in the chat section if this is clear to you. Let me give you some examples now. Let me give you some examples. Very good. All right. Great. See, now this is your first compound. This is your first compound. Cyclic. Tell me. Cyclic? Yes. Planar, yes, because all are what? Double bonded carbon. Double bonded carbon has hybridization sp2. Resonance possible. Tell me which type of system is there in resonance. Tell me which type of system is there in resonance. Tell me in the chat section. What type of system is there in the resonance? What type of system is there for the resonance? Double, single, double. Double, single, double. So resonance is also possible. Okay, this is a pi bond, this is a pi bond. So how many pi bonds? 2 pi bonds. So pi electrons, 4 pi electron. 4 pi electrons. So it is what? Anti-aromatic. AA is anti-aromatic. Are you getting my point? Now tell me whether this is anti-aromatic or not, or how many pi electrons it has. How many pi electrons it has? Come on, tell me. This is your second question. Come on, everyone. Come on, everyone. Tell me how many pi electrons it has. Pi electrons are those which are participating in resonance. Just see what all electrons are participating in resonance. Yes, great Richu, solo guy, Rajni, fantastic, great. See, this bond is participating in resonance, as well as this is also participating in resonance. So one bond, 2 electrons, and this lone pair, 2 more electrons. So 4 pi electrons. So it is again what? Anti-aromatic. Alright, okay. Now tell me this. Come on, tell me this. This, how many pi electrons it has? How many pi electrons it has? How many pi electrons it has? See, this pi bond, yes, as well as this lone pair. So again it has 4 pi electrons. So it is also what? Anti-aromatic. 4 pi, 8 pi, 12 pi. These all are examples of anti-aromatic. Are you getting my point? Alright, now you can also identify anti-aromatic compounds also. Alright, third type of compounds are non-aromatic. 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 This is very simple. This is very simple. If you know aromatic and anti-aromatic, you already know non-aromatic. Compounds which are neither aromatic nor anti-aromatic are called non-aromatic compounds. Alright, this is a very easy thing, right? We know how to identify aromatic, we know how to identify anti-aromatic. So anything which is not aromatic, which is not anti-aromatic, that is non-aromatic. Are you getting my point? Alright, so see, now suppose this is your structure. This is this non-aromatic? Tell me in the chat section. This is non-aromatic or not? This is non-aromatic or not? And tell me why this is non-aromatic. Why? This is non-aromatic or not? This is not cyclic. Not cyclic. So if this is not cyclic, this is non-aromatic. Simple. Because see, for anti-aromatic, your compound needs to be cyclic. For aromatic, your compounds need to be cyclic. If it is not cyclic, then it is what? Non-aromatic. It is not cyclic, na? Great solo guy. Yes, Rajni. Great Nagendra. Alright, are you getting my point? Now see, if this is the structure. Now this is the structure. This is the structure. Now tell me if this is non-aromatic or not. Now this is non-aromatic or not. Tell me. Very simple, very easy. Tell me. This is non-aromatic or not. I have explained you the hybridization. Carbon single bond carbon is sp3. Carbon double bond carbon is sp2. Carbon triple bond carbon is sp3. Hybridization of this is sp3. Hybridization of this is sp3. sp3 means non-planar. Non-planar. Now the conditions for aromatic and anti-aromatic were the compound has to be what? Planar. Right? So this is non-planar. So non-planar means it is non-aromatic. Is this much clear to you? Yes, Richu, we need to consider only one. We need to consider only one. Yes. Yes, Rajni, resonance is also not there, as well as it is non-planar, so it is non-aromatic. Great, great, great. Alright. Now let me give you one exception of this. Let me give you one exception of this. Exception is this. This is your exception. This is your exception. Now tell me how many pi electrons it has. Now tell me how many pi electrons it has, and according to you, it should be aromatic or anti-aromatic or non-aromatic. Tell me. According to your knowledge, I will tell you what is the exception here. Just tell me according to your knowledge what it should be. Nagendra, sp2 is planar. sp3 carbons are not planar. Yes, it has 8 pi electrons. It has 8 pi electron. So it should be what? According to our rules, 8 pi electrons are what? See, just check here. 8 pi electrons are what? Anti-aromatic. Anti-aromatic, right? But the exception is it is non-aromatic. It is non-aromatic. Why? Why? Now, if you have ring size of 8 carbon, if you have a ring size of 8 carbons, these are converted into like these structures. This would be converted into this type of structure due to repulsions. It is converted into this type of structure due to repulsions. This type of structure. These are known as puckered structures. These are known as puckered structures. These are non-planar. These are non-planar. If these are non-planar, so it should be what? Non-aromatic also. So if the ring size is of 8 electrons or more, 8 electrons or more, they, due to repulsions, they come out of plane. So if they come out of plane, they become non-aromatic. Non-aromatic. Is this much clear to you? This was an exception. You need to remember this. You need to remember this. Alright, this much clear to all of you? Tell me in the chat section. Give me a thumbs up. Give me a thumbs up. Rajni, Nagendra, Solo Guy, Richu. Give me a thumbs up in the chat section. Alright, this was an exception. This was an exception. Now, stability order. Stability order. How we have defined aromatic compounds. Aromatic compounds are extra stable, or very, very high stability of aromatic compounds. How we have defined anti-aromatic, extra unstable compounds. Extra unstable, and non-aromatic in between aromatic and anti-aromatic. Alright, so stability order is aromatic compounds are very highly stable. Then you have non-aromatic, and you have anti-aromatic as your least stable compounds. This is your stability order. So whenever stability is being asked to you, you sometimes need to check whether the compound is aromatic, non-aromatic or anti-aromatic, and accordingly you will decide their stability. If it is aromatic, it is highly stable. If it is anti-aromatic, it is highly unstable, and non-aromatic is in between those two. Is this much clear to all of you? Give me a thumbs up in the chat section if this is clear. Alright, if this is clear, give me a thumbs up in the chat section. This was all about aromaticity. This was all about aromaticity. Your aromaticity is related to your resonance only. So if you haven't watched the resonance video, you can go and watch my video on this channel only. I've very much in detail, I've explained you each and every concept of resonance. Alright, so is this clear to all of you? Now let us move on to our next topic. Today's next topic. A name, there is no name for such structure. Rajni, there is no name of such kind of structures. These are known as puckered structures. The class of compounds are known as puckered structures. Great. Now we are going to study about, see, we have completed resonance. We have completed very much in detail about resonance. Now we are starting another electron displacement. See, just pay attention here. Electron displacement methods. Electron displacement methods. Alright, there are basically three types of electron displacement methods. First was resonance. Alright, second is inductive effect, and third is hyperconjugation. Alright, so we have covered resonance, and now we are going to cover inductive and hyperconjugation in today's class. Alright, we have covered resonance in very much in detail. So are you guys ready for it? Let us start our inductive effect, another electron displacement method. Alright, inductive effect. Alright, now just pay attention here. Suppose this is your carbon. These are your carbons. Alright, now suppose if I apply here, if I add here fluorine. Suppose fluorine. Alright, mesomeric effect is same as resonance only. Yes, Richu. Alright, resonance is also known as mesomeric effect. It is same. Alright. See, now see, inductive effect. Now this is a carbon chain. I have applied fluorine at the corner of it. Now fluorine has high electronegativity. It is very powerful. So these shared pair of electrons are tilted towards fluorine, correct? Because it has what? High electronegativity. So if they are shifted towards fluorine, so fluorine acquires del negative. A slight negative charge acquires fluorine. So if here it is del negative, this carbon must be having del positive. Why? Because the electrons are shifted away from it. Got it? Now in turn this carbon is del positive. Now it is saying, oh no, we have become positive. Now we need electrons. So in turn this carbon attracts this pair of electrons also with itself. So this carbon has del positive, even a smaller charge develops on it. So in turn this carbon is attracting this electrons, so it has having del plus. Similarly this is also having del plus. So after 4 carbons this effect is almost negligible. Alright, so now tell me why all these carbons have acquired del positive charge. Tell me, because of which atom all these carbon atoms have acquired some charge. Why? Because of this fluorine. Fluorine started attracting electrons towards itself due to its high electronegativity, which in turn are attracting all further electrons. Alright, so this is known as inductive effect. Now let me tell you definition of this. Let me tell you definition of this inductive effect. This is proper definition. We need to write proper definition of this inductive effect. So see, all the bonds in carbon carbon and with carbon fluorine are what? Single bonds. Are what? Single, or we can write them as sigma bonds. We can write them as sigma bonds. So we say displacement of sigma electron along saturated means carbon single bond carbon, because of displacement of sigma electron along a saturated carbon carbon bond is known as inductive effect. Are you getting my point? All right. Why? Because all the bonds must be what? Single bond or sigma bond. All right. Next point is inductive effect. Inductive effect operates through sigma bond. All right. Why? Because all the bonds must be what? Single bond. So it operates through sigma bonds. Next point is it is distance dependent. It is distance dependent, and with distance it decreases. Why? See, because here also in this example also the positive charge is decreasing continuously, because the effect of fluorine is getting minimized as the distance increases. All right. So these were basic examples and basic definition, basic understanding of inductive effect. All right. Is this much clear to you? Give me a thumbs up in the chat section. Is this much clear to all of you? This is quite easy. This is quite easy. Alright, just give me a thumbs up in the chat section, everyone. Yes, great. Now see, again these are of two types. Inductive effect is of two types. Alright, similar like resonance was of two types. Yes, solo guy, you will be. I'll explain again. See, it is distance dependent. Why? Because this fluorine, as you will go away from this fluorine, positive charge is decreasing on carbon. Its effect is getting minimum. Its effect is getting neutralized as distance increases. All right. Yes. See, resonance were also of two types, plus R and minus R, if you remember that, right? Similarly, inductive effect is also two type. First is minus I. Minus I means electron withdrawing groups. This is minus I. Electron withdraw. They withdraw the electron. This is known as minus I. Alright. Now, how to identify minus I electrons? They are highly electronegative. They are highly electronegative atoms. Right? Why? Because if they are highly electronegative atoms, they will attract the electrons. Or they will withdraw the electrons from carbon. Correct? Are you getting my point? Alright, now there is a series. Suppose the examples of minus I are NO2, right? Nitrogen and 2 oxygen, highly electronegative atoms. They will do? They will attract, they will withdraw the electron from carbon. Cyanide. Similarly, COOH, 2 oxygen, nitrogen, these are highly electronegative atoms. Similarly, fluorine, chlorine, bromine, iodine, halogens, these are all what? Highly electronegative atoms. So this they will behave as minus I groups. Is this much clear to all of you? Is this much clear to all of you? How to identify your minus I compounds? These are highly electronegative atoms. Highly electronegative atoms. Clear to all of you? Shall we move on to our next type? This is a very easy. Inductive effect is very easy. Alright? Yeah. If they have highly electronegative atoms, this means they have minus I tendency. They have minus I tendency. Oxygen, OH, minus I tendency. Yeah. Yes, this is order also. NO2 is largest, cyanide, COH, fluorine, chlorine, bromine, iodine. This is in order also. This is in order only. I have written in order only. NO2 has highest minus I. Alright? Great. Great Nagendra, Richu, Solo Guy. Richu, this is order only. I have given the order. I have written this, no? This is your highest minus I showing group. Alright? Great. Now let us go for plus I effect. Plus I effect. What is plus I? Plus I are electron donating groups. These are electron donating groups. Alright? They donate their electrons. Yes. Positive charge, Rajni, yes. Positive charge means they are creating electron deficiency. Yes. That's why they are electron withdrawing groups. So electron withdrawing groups would always create electron deficiency in the carbon chain. Yes. Alright. So plus I effect, electron donating groups. Now basically CH3 group shows plus I effect. CH3 group shows plus I effect. Why? Due to repulsions. CH3 group would show plus I effect. Alright? Alright. Great. NO2 has the highest this thing. NO2 has the highest minus I effect. Alright? We can't compare as such NF3 and NO2. See, there are parameters on which these are compared. You cannot directly just say like if it has the fluorine atoms, it would be more minus I. There are more parameters. Alright? NO2, just simply remember NO2 has more minus I. So see, let me complete this plus I effect. The CH3 groups show plus I effect. CH3 groups would show plus I effect. So why? Due to repulsions. Now just tell me this. CH3, CH3, CH3. One is this. CH3, CH, CH3. Another is this. CH3, CH2, like this. And your CH3, simple CH3. So which group would have greater plus I? That group would have greater plus I which has more CH3 groups. So this has 1, 2, 3 CH3 groups. So this is highest plus I. This has 2 CH3 groups. This is highest. This has 1 CH3 group. This is highest. And this has no as such extra CH3 group, so this is lowest. Alright, yes, these are in decreasing order. Great, because it has more CH3, so more repulsions, therefore more plus I. Are you able to understand this? Just remember, CH3 group shows plus I effect. Is this much clear to all of you? Is this much clear to all of you? If you have any doubt, just tell me in the chat section. I'll clear all your doubts. Just tell me in the chat section if you have any doubt. If you have any doubt, tell me in the chat section. I will clear it. Is everything clear? Up till now, is everything clear? Great. Fantastic. So basically inductive effect is very basic effect, your inductive and your plus I and minus I. minus I you need to identify it with highly electronegative atoms, so this is the series, and plus I you need to identify with CH3 groups. CH3 groups means more the CH3 groups, more is the plus I. I'm telling you about identification also. Alright. Now see what type of questions are being asked here. What type of questions are asked here? See, question is determine stability, determine stability order. Alright. Now suppose there is this fluorine and this is plus, this is chlorine, this is here, this carbon has plus, and this is bromine, this carbon has plus. So see, now we know this fluorine, chlorine and bromine would show what? Minus I effect. Alright. Every compound wants to be in neutral state, every compound wants to be in a neutral state. So see, this is what? Positive. This is what? Positive. This means it is what? Electron deficient. This is what? Electron deficient. So those species which will donate electrons, which will give their electrons to them, they will what? They will bring them in neutral state, and then hence they will increase their stability. Correct. So see, this is fluorine, this is chlorine, this is iodine. All are electron withdrawing. They are withdrawing electrons from positive charge. That is bad. That is not good. They will decrease their stability. So fluorine is highly electron withdrawing. It has more electronegativity. So what? So this will decrease your stability more. So what should be your answer? This should be your answer. Why? Because bromine is not very much electronegative, this will not withdraw electrons very much. Is this much clear to all of you? Yes, Solo guy, Rajni, great. Is this much clear? Fantastic. Yes. Very good. Now suppose on the other hand, we have this. Now suppose we have this compound, this, and this. Suppose we have this compound. Suppose you have this compound. So these are all showing what? Plus I. These are all showing what? Plus I. This is also showing plus I. Alright. So plus I means this will donate electrons. Donate electrons means they will give this positive charge their electrons. So if they will give their electrons, this means they must neutralize it. They will increase the stability. So this should be your order. Why? Because this will show more plus I, this will show less, and this will show even less plus I. Alright. We will take a lot of examples in further classes. These type of examples. We will take a lot of examples. You will be very much clear with it in further classes. Alright. This was just to show you a glimpse of what we are going to do in further classes. Alright. Yes, Solo guy. Great. Is this much clear to all of you? Tell me in the chat section. Is this much clear? If this is clear, just like this video. Great. Alright. So this was all about inductive effect. Alright. We have covered our one more electron displacement effect. First we have covered resonance. Then we have covered inductive. Now we need to study about hyperconjugation, our last effect. Alright, hyperconjugation. Let me introduce you to hyperconjugation. Alright. practice session and the next class, in the next organic class, we'll be practicing all this resonance inductive hyperconjugation. We'll be practicing everything in our next organic class. All right, we are only going to do questions and questions, that's it. Let me introduce you all hyperconjugation. Just please pay attention here. Everyone try to pay attention here. Yes. Great, 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 great. All right. Now see, suppose this is CH, here also H, here also H, CH double bond CH2. All right. Now what happens in hyperconjugation? What happens in hyperconjugation is this hydrogen and carbon is having some bond. All right. This bond is broken and this bond is shifted here. This bond shifts here, and this pi bond shifts here. This is a sigma bond. This is a sigma bond. All right. This is a this is a sigma bond. This is a sigma bond. This is a pi bond. All right. So sigma bond is shifting here. Pi bond is shifting on this carbon. Let me draw this hyperconjugating structure. See, this hydrogen and this hydrogen are intact. See, this bond has come over here. So this and this carbon are having double bond now. And there is no bond between this hydrogen and this carbon. There is no bond between this carbon and this hydrogen. Please wait. Let me explain you everything first. Now this is this hydrogen. Now this pi bond is shifted on this carbon. So it has CH2 negative. CH2 negative. Now you must be wondering why only this? Why only this hydrogen? This hydrogen can also go similar fate. We can do similar thing with this carbon also, this hydrogen also. So see, one more structure can be, see, this H is now intact, this H is now intact. This hydrogen and this carbon are not having any bonds. This bond is shifted to here. So this means this has double bond CH, and this pi bond is shifted to here. So CH2 negative. Correct? Now similarly you must be thinking this carbon can also go like this only. So you can draw like this also. This bond here and this pi bond here. So you can draw like this also. C H H, here it is positive, CH double single bond CH2 negative. Now again this carbon, this hydrogen and this carbon has no bond. Alright, so this is hyperconjugation. Now what is happening in hyperconjugation? Just please pay attention. This sigma bond is converted into this pi bond. See. Alright, so in this hyperconjugation, sigma bond is converted into pi bond. Alright, now again carefully see, this pi bond are shifted to this carbon. So these are converted into this negative charge. Negative charge means lone pair. So pi bond is converted into lone pair. Pi bond is converted into lone pair. Are you getting my point? Is this much clear to all of you? Tell me in the chat section if this is clear to all of you. You need to attend all regular classes or not complete class. I'll be taking more examples of this only. Is this much clear to all of you? Is this much clear to all of you? Great. Yes, Richu. Yes, Richu. So first line, which first line, Nagendra? Oh, sorry. Sorry, yes. Sigma bond is converted into pi bond. Yes. Sigma bond is converted into pi bond. Yeah, my mistake. sigma bond is converted into pi bond. Now good? Everything good? Tell me, thumbs up in the chat section. Now hyperconjugation is also known as no bond resonance, is also known as no bond resonance. All right, why? See, because there are structures in which there is no bond between this carbon and this hydrogen, no bond between this carbon and this hydrogen and this carbon. So this are known as no bond resonance. Hyperconjugation is also known as no bond resonance. All right, so see, now how many see, in resonance we used to call them resonating structures. In this we will call them hyperconjugating structures. We will call them hyperconjugating structures. How many structures are there? Or HS. This is your first HS, this is your second HS, this is your third HS. So how many resonating structure hyperconjugating structures? 3 hyperconjugating structures. Now you must be wondering why these 3 hyperconjugating structures only. Why? Because only 3 hydrogen were present. Only 3 hydrogen were present. That's why only 3 hyperconjugating structures. Alright. Now let me give you some conditions. Conditions for resonance. Conditions for resonance. Sorry. Conditions for hyperconjugation. We are studying hyperconjugation now. What are the conditions in which hyperconjugation is applied? What are the conditions? See, only one condition, but very, very important condition. There must be alpha hydrogen. There must be alpha hydrogen on sp3 hybridized carbon. On sp3 hybridized carbon. If there are alpha hydrogen on sp3 hybridized carbon, hyperconjugation is possible. Let me explain you this. Now see, this is your double bond. This is your double bond. Alright, this carbon is known as alpha carbon. Alright, alpha carbon. And these hydrogen which are attached to alpha carbon are known as alpha hydrogen. Alpha hydrogen. Alright, now tell me what is the hybridization of this? Tell me what is the hybridization of this carbon? I have explained you multiple times. Carbon single bond carbon, so it means it is sp3. Carbon double bond carbon, so it means it is sp2. Carbon triple bond carbon, it means sp. So hybridization is sp3. So hyperconjugation is possible. Are you getting my point? Yes, great Richu, Nagendra, fantastic, very good. Alright, again tell me which is alpha, how many alpha hydrogen it has? How many alpha hydrogen it has? And tell me whether hyperconjugation is possible or not. Tell me in the chat section. Tell me, come on. How many alpha hydrogen? See, this is your double bond. This is your alpha carbon. Only this is your alpha carbon. This is not your alpha carbon, which is directly attached to double bond. That is your alpha carbon. So it has only these two hydrogen. So 2 alpha hydrogen. Alright, hybridization of this alpha is, sorry, this alpha carbon is sp3. So hyperconjugation possible. Great. Are you able to understand now, Ayush? Hyperconjugation is possible. It should have alpha hydrogen and it should be on sp3 hybridized carbon. So it is possible. Nagendra, what is the doubt here? Tell me. You guys can ask any doubt if you have any. Now tell me how many alpha hydrogen this has. Now tell me how many alpha hydrogen this has. How many alpha hydrogen this particular compound has? Tell me in the chat section. This is your double bond. Now all those carbons which are directly attached to double bond are alpha. This is your alpha. This is your alpha. Both are alpha. So here 2, here 3. So this as 5 alpha hydrogen. And hyperconjugation is also possible. Great, Ayush, Richu. Nagendra, is everything clear? Solo guy, great. 5 because it has 2 and it has 3. You need to add each and every alpha carbon, alpha hydrogen. All right. Okay, now tell me this, how many this has? Now suppose this is your positive charge. This is your positive charge. Now just take this as your main thing and decide which is your alpha carbon. Now decide which is your alpha carbon. This is positive charge. Now take this as your main thing. Now how many alpha hydrogen? Tell me. Tell me how many alpha hydrogen? Solo guy, we need to see the carbon which is directly attached with this positive charged carbon. Only this carbon is your alpha. This is alpha carbon. Not all these are not directly attached. Directly attached. So if this is your alpha carbon, it has no hydrogen. So 0 alpha hydrogen. 0 alpha hydrogen. Alright. If 0 alpha hydrogen, this means no hyperconjugation. No hyperconjugation. Are you able to understand this? Just give me a thumbs up in the chat section if this much is clear to all of you. Give me a thumbs up in the chat section if this is clear to all of you. Give me a thumbs up in the chat section. Come on. Great, great. Now I'm writing one note here. I'm writing one note here. More the number of alpha hydrogen, more the number of alpha hydrogen, more are the hyperconjugating structures. All right. So right, if there are 3 alpha hydrogen, 3 hyperconjugating structures. If there are 6, there are 6. All right. More the number of alpha hydrogen, more are the hyperconjugating structures, and more the number of hyperconjugating structures, more is the stability. More is the stability. So if I write directly that stability is directly proportional to number of alpha hydrogen. If there are more number of alpha hydrogen, the stability is more. I am writing it directly. All right. Because if there are more alpha hydrogen, there are more hyperconjugating structures, and there are more hyperconjugating structures, more is the stability. Is this much clear to all of you? This is a very, very important note. Very, very important note. Very important. Tell me in the chat section if this much is clear to all of you. Come on everyone, tell me in the chat section if this is clear to all of you. If you have any doubt, I can wait and I can answer all your doubts. I can wait and I can answer all your doubts here. If you have any doubt, or shall we move on to our applications of hyperconjugation? Guys, if you have any doubt, please ask me. Is everything clear to all of you? Richu will be studying carbocation and carbanion in our next class. Is everything clear? Shall we move on to our applications of hyperconjugation? Application of hyperconjugation. Application of hyperconjugation. What is the application of hyperconjugation? It is used to decide stability of alkene. It is used to decide stability of alkene. Alright, it is used to decide stability of alkene. How? Let me tell you. Now suppose these are all your examples. Now you would only tell me. Alright, I have explained you. Based on it you can easily determine it. I am giving you, this is a type of example only for all of you. Alright, just try and attempt all these things. Attempt. Now this is your A, this is your B, similarly C, D and E. All these are your alkenes, right? Alkenes is what? Carbon, double bond carbon. Try. Tell me, just okay. Just tell me how many alpha hydrogen each one has. How many alpha hydrogen each one has? Just tell me this. How many alpha hydrogen each alkene has? If you'll tell me this, now we know more the number of alpha hydrogen, more would be the stability. We can decide based on it. Just tell me how many alpha hydrogen they have. Tell me how many alpha hydrogen they have. They all have. Great, Richu, Rajni, Harsha. Try to answer in the chat section, everyone. Please be active on the chat section. I should know you guys are able to understand each and everything. Come on, everyone. Come on, everyone. Yeah. Yes. Yes, Solo Guy, Rajni, Harsha, Richu. Great. Now see, this is your main thing. Now just see what are alpha carbon. This is your alpha carbon, this is your alpha carbon, this is your alpha carbon, this is your alpha carbon. This hydrogen, this hydrogen, this hydrogen, this hydrogen, all these are hydrogen. So alpha hydrogens, this has 12 alpha hydrogen. Now similarly, this is your double bonded carbon. This is alpha, this is alpha, this is alpha. First identify alpha carbon. Don't consider this. You need to first identify alpha carbon. Alright, so here 3, this 3 and this 3. So it has 9 alpha hydrogen. Similarly, this is your alpha, this is your alpha. Inko consider, you don't need to consider these things. Alright, these hydrogens, this 3, this 3. So it has 6 alpha hydrogen. Similarly, this is your alpha, 3 alpha hydrogen. And there is no alpha, we don't consider here any hydrogen. So it has 0 alpha hydrogen. Alright, So A is the most stable one. Why? Because it has a maximum number of alpha hydrogen. So what is the order? A, B, C, D and then E. Very, very good. Easy. Tell me in the chat section if this is easy or not. Tell me in the chat section if this is easy or not. Very easy. Alright. Second application is great, Rajni. Great. Yes, Richu. How hyperconjugation works for carbocation, I'm just going to explain you right now. Great, Harsha. Great. Now, second application is used to find stability of carbocation. Let me explain you this. How hyperconjugation is possible in carbocation. See here, hydrogen, 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 CH2 positive. Now this is your carbocation. Now again what happens? This bond, this bond between hydrogen and carbon is shifted to here. What happens? See, this hydrogen are same. Now this sigma bond is converted into here. So this means it has double bond, and if carbon is forming 4 bonds, it is stable, and here it is positive charge. Got it? Now again you must be wondering, same fate can be of this hydrogen. So again we can make carbon, hydrogen, hydrogen. This bond is coming here. So H plus double bond CH2. Alright. Similarly, your the same fate can be of this hydrogen. What happens? C here hydrogen, here hydrogen, here it is H plus double bond CH2. Alright. So how many hyperconjugating structures? Again, one HS, second HS and your third HS. 3 hyperconjugating structures. Why? Because there were three alpha hydrogen. Are you able to understand this? Now how do we determine stability based on this? Again, if any carbocation would have more alpha hydrogen, this means that would have more stability. Let me give you this example. Come on everyone, you need to attempt this. You are very much now able to, I hope you would be very much able to attempt this, and very correctly also. Alright, answer this. These are all carbocation. You need to answer this. This is your A, this is your B, this is your C, this is your D. Stability orders. Stability orders. Come on everyone. Come on everyone. Great Harsha, fantastic. Just check alpha hydrogen. Just check alpha hydrogen. You will be getting it. Great Richu. Great Rajni. Fantastic. Any more answers? Solo guy. See, this is your alpha. This is your alpha. This is your alpha. 1 3 3 3, so it has 9 alpha hydrogen, correct? Now this is your alpha, this is your alpha, which are directly attached to your carbocation. All right, so you need to consider only these hydrogen. You don't need to consider this. It has 6 alpha hydrogen. First identify alpha carbon, then identify alpha hydrogen. Here it is this alpha, only 3 alpha hydrogen and 0 alpha hydrogen. More the alpha hydrogen, more is the stability. A is most stable, then B, then C, and last one is D. Fantastic. Very good. So see, now again let me tell you this type. See this carbon, just tell me in the chat section with how many carbons this particular carbon is directly attached with how many carbons? Tell me in the chat section. Tell me in the chat section with how many more carbons this our positive charge carbon is attached directly. Yes, with 3, this carbon, this carbon, and this carbon. So these type are known as 3 degree. Similarly, this is 2 degree, this is 1 degree, and this is your base. We don't consider it in a degree. This is your base structure. All right. So most stable carbocation are 3 degree, then 2 degree, then 1 degree. Carbocation stability is 3 degree, 2 degree, 1 degree. We will be learning this again very much in detail in further classes. Alright, right now I have just given you a brief hint. Is this much clear to all of you? Give me a thumbs up in the chat section if this is clear to each and every one. Alright, great. Now one small topic is left in hyperconjugation, its types. See, we have studied resonance. How many types? 2, plus r minus r. We have studied inductive. How many types? 2, plus I minus I. We are studying hyperconjugation. How many types? Tell me. 2 types. Same 2 types. First is your plus H. Now plus H are all plus. Whether it is plus R, plus I, or plus H, all are electron donating groups. Alright, just pay attention here. This is your last topic. I need your complete focus here. Alright, plus H, electron donating groups. See, this is your benzene. This is your, suppose, benzene. Alright, and you have your CH3 here. Now what is your main thing? Main thing is your benzene. Benzene. Alright, so this carbon is known as alpha carbon. Alright, and how many hydrogen it has? 3 hydrogen. So there are 3 alpha hydrogen in this. Alright, now how does hyperconjugation happens? Now see, please pay attention here. Now see, this bond between this carbon and hydrogen is shifted here, and this pi bond is shifted here. Alright, what happens? Just see, just draw the complete structure as it is, the remaining structures here. This carbon and this carbon would be having double bond because the bond has come here, correct? These hydrogen are same. This hydrogen and this carbon are not having any bond, H plus. Alright, and this pi bond is shifted on this carbon, so it is having negative charge. Alright. Now tell me, in the benzene ring, is resonance possible? Tell me, in the benzene ring, is resonance possible? Yes. Double bond, single bond, lone pairs. Alright, so what happens? This lone pair are shifted here and this pi bond is shifted on this carbon. So what is the structure now? See, first draw the remaining structures. You have not touched this structure, you have drawn this as it is. Now what happens? This pi bond are shifted to here. So pi bond comes here and negative charge comes here. Alright, if you carefully observe what this CH3 groups, this is a CH3 group. What is it doing? It is donating electrons. Why? Because if you observe carefully on the benzene ring, you are having negative charge. Negative charge means someone has given you more electrons. So who is that someone? CH3. Alright, so what does plus H means? They increase electron density on benzene. They increase electron density on benzene. Are you getting my point? Is this much clear to all of you? These are electron donating. They are electron donating groups. Electron donating increases electron density on benzene. This much clear to all of you? Plus H means electron donating. plus H means electron donating. Alright, now let me show you plus H order. Plus H order. Let me show you plus H order. Please pay attention here. See, this is your benzene. This is your benzene. Now suppose it has CH3. Alright. Now suppose it has, I'm giving you order. This is very important and many students are confused in this. I want you to be very much clear with it. From today onwards, you need to be very much clear with this. Just tell me alpha hydrogen in all these structures. Tell me alpha hydrogen in all these structures. Consider benzene as your main structure. Tell me alpha hydrogen in all these. Come on. Tell me alpha hydrogen in all these structures. Consider benzene as your main important thing. Fantastic, Harsha, Rajni, great. Yes, only this carbon which is directly attached to benzene is your alpha carbon. This is your alpha, this is your alpha, this is your alpha, this is your alpha. Alright, so it has 3, it has 2, it has 1 and it has 0. So this has 3 alpha hydrogen. Great solo guy, fantastic. This has 2 alpha hydrogen, this has 1 alpha hydrogen and this has 0 alpha hydrogen. So which one would show more plus H? Which has more number of alpha hydrogen? So order of plus H is this. Are you able to understand this now? This is very confusing to a lot of students, but I want you all to be very much clear with it. Great. Yes. Give me a thumbs up if this is clear to all of you. Give me a thumbs up if this is clear to all of you. Alright. This was all about plus H. Let me show you more examples. Great Richu, Harsha, Rajni, solo guy, fantastic. Now let me talk about other type of hyperconjugation. This is minus H. Minus means electron withdrawing groups. Alright, let me show you how this works. Now suppose you have this benzene and you are attaching CF3 with it. CF3 fluorine. Alright, now just pay attention here. Come on everyone, your complete attention here. What happens in this case? In this case, fluorine are what? Highly electronegative atoms. If they are highly electronegative atoms, what happens? This pi bond shifts here and this sigma bond is shifted on fluorine, because fluorine is saying I am very highly electronegative atom, I will take electrons. So what happens? Just see. Just pay attention here. Whatever you have not touched, you draw it as it is. This pi bond is shifted here. Alright, so it has double bond. This fluorine is same, this fluorine is as it is. This bonds are being taken by this fluorine. So this has negative charge. Alright, and these pi bond are shifted here. So this is acquiring positive charge. Alright, now tell me in the chat section if is resonance possible here. In benzene, is resonance possible? Tell me in the chat section. Is resonance possible, and if it is possible, what type of system is there? What type of system? Double bond, single bond, empty orbital. Plus charge means empty orbital. So further what will happen? This pi bond is shifted here. So you have this type of structure. Alright. So positive charge is here. Now if you carefully observe a benzene ring is having your positive charge. So that's why we are saying them as electron withdrawing. They are withdrawing electron. They decrease electron density on benzene. They decrease electron density. That's why we are saying that decreasing electron density. They are having positive charge on electron on benzene ring. Is this much clear to all of you? They decrease electron density on benzene. All right. That's why we are calling them as electron withdrawing. They are withdrawing electron from benzene. Okay. Now tell me minus H order. You will only tell me minus H order. CF3, CCl3, CBr3 or CI3. Okay, let me attach everything this on benzene. This is your A, similarly this is your B. Tell me which has, what is the order of minus H? What is the order of minus H? Come on everyone. What should be the order according to you? What should be the order according to you guys? What should be the order? What should be the order? Everyone be active. Richu, Rajni and Harsha have given their answers. Rest all also give your answers in the chat section. Great Harsha, great Richu, great Rajni. Everyone be active on the chat section. Yes, because fluorine is highly electronegative, so that will withdraw most electrons. Alright, so this is your order. Fantastic. Great. Today's lecture is very important. Let me tell you, in all the further classes of organic, you will be needing this lecture. This is very important. Resonance, hyperconjugation, inductive are very important. Alright. One just theory part. This minus H is also known as reverse hyperconjugation. This is also known as reverse hyperconjugation because it is just acting as your plus H and minus H. So minus H we are calling it as reverse hyperconjugation. Just a theoretical part. Alright. Now please pay attention here. We have studied 4 things. We have studied aromaticity. We have studied resonance. Alright. We have studied inductive. We have studied hyperconjugation. Now just I am writing note here. I am writing note. Note is order of impact. I mean all these 4 out of these, all these 4 phenomena, which of them has the most impact, which are most powerful. So aromatic are most impactful. Then you have resonance. Then you have hyperconjugation. Alright. And then you have inductive. Why? Aromatic are what? Highly stable compounds. I have explained you they are highly stable compounds. Thank you, Ankit. Thank you. Alright. Now the impact of resonance is, why resonance is more impact? Because resonance involves shifting of pi electrons, and pi electrons are loosely bound. They can be easily shifted. So resonance have more impact. Alright. Similarly, hyperconjugation has sigma and pi. It has both, so it has comparatively less. Inductive is saying I only operate through sigma bond. I am the weakest among all. Alright, so note is order of impact. Aromatic compounds are highly impactful, then resonance, then hyperconjugation, then inductive. Alright. Tell me in the chat section if this is very much clear to each and every student. Tell me in the chat section. This is very much, these things would be very much needed in the further classes. Give me a thumbs up. Yes, Richu, I'm telling you, next session of organic, we are having detailed questions, only questions. I'll be explaining you only questions. All right, lot of questions we are going to practice. Don't worry about it. I'll just sit and you guys need to do all those questions. All right. All right. Is this much clear to each and every student? Is this much clear? All right. So see, today we have studied lot of things. We have studied aromaticity, we have studied inductive, we have studied hyperconjugation. In previous class we have studied resonance. So these all lectures are really important, and you need to be very much be good at it. If you haven't watched the resonance video yet, please watch it. This is very important thing. These all are very important for organic chemistry. All right, so if you have any doubt, you can ask me in the chat section. Richu, yeah. See, you need to be comfortable with it. Whichever tutor you need, if you are able to understand my lectures, you can surely continue it. Otherwise, you need to make that decision. All right, you need to make that decision. All right, all right, Richu. In next class, we'll be having very detailed discussion. All right. So this is my code, Nitesh YT. Nitesh YT. Whenever you buy the subscription, just apply this, you'll get your 10% off. All right, so just like this video and subscribe to this channel and hit the bell icon. All right, and I will see you in the next class. Tomorrow we will study physical chemistry. Tomorrow we'll study physical chemistry concentration terms. All right, yeah. Good morning, Jitendra. Good morning. All right, so let us end this class at 11 a.m. At 11 a.m. we will again meet you. I will again meet you all 11 a.m. tomorrow. All right, inorganic chemistry also we are going to take in between. Yes. All right, bye bye. Bye bye, take care. Bye bye everyone, take care. Have a nice day. Take care everyone, have a nice day. Bye bye. See you tomorrow at 11 a.m. See you tomorrow. Take care everyone. Like this video. Like this video. Bye bye.